Good afternoon again. So this is ellipsoidal coordinates. We are on lecture 7. So last time I discussed you the difference between reference system and reference frame. So this time I'm going to discuss first an example exercise of the lecture 5, which is on reference ellipsoid as a review before we proceed to the this topic, which is ellipsoidal coordinates, the relationship between our latitudes. So basically, we have three latitudes, that is the centric, geodetic, and the reduced latitude. So this is very important since some of the problems are using different kinds of latitude since we are using different kinds of ellipsoid. So let's have first this example. After this one, we are going to proceed to the proper topic of this presentation, which is the relationship between the latitude. So let's have this problem first. So you are given with the value of a semi-major axis, which is A 6377802 meters. So this is denoted as A. So and then 1 over F is 290.8642. So we don't know what is the name of this spheroid, and where F is the flattening of your spheroid. So we are going to compute for the value of a semi-minor axis, which is denoted as, we usually denote this as B. So let's have first the given. So let's write given. So our given, we have the given the semi-major axis denoted as A. And the other one is the inverse flattening, which is 1 over F, which is 290.8642. Now, we are required to compute for the semi-minor axis denoted as letter B. So this is the required. I'm sorry, I have problems with my pen. I don't know why this pen is doing something this one. And we are going to solve for B. So the relationship that we know is that flattening is equivalent to A minus B all over A, right? And we already know what is F, but the given F is inverse flattening. So if you are going to transpose F into 1 over F, so if this is the take the ratio of F, which is 1 over F, which means we also take the inverse ratio of this one. So this will become A over, so babaligtarin din natin, A minus B. So in this formula here, we already have the value of A, and then we already have the value of B, F, and we don't have the value of B since it's the required one. So by using this one, we can cross multiply this. Then this is A minus B is equal to A times the value of F, right? And then this one, if we substitute the value, 1 minus F is equivalent to 290.8642, right? That's 290. 206.8642 is equal to, we have A, we have 6377802 over 6377802 minus B. Then we may cross multiply that one. That is 637. I don't know what's wrong with my pen. That's a 6377802 minus b is equal to 6377802 all over 290.8642. Okay, so now we transpose this right side 6377802 to the right side. This will remain b now is equal to how much? This is 6377 6377802 minus the ratio of 290.8642, then 6377802 meters. Then P is equal to, just check my answer, if my answer is correct, if this is equal to 6355874 874.922. So just check if we have the same answer. This is equal to, this is 6355874.922 meters. So this is now the value of, okay? So just remember the formula and computing the flattening eccentricity, linear, and the angular eccentricity, and you are good to go. Okay, and be familiarized with the value of the parameter A and B, or the inverse flattening for the different ellipsoid. Okay, so now we have the relationship between the latitudes. So basically we have three latitudes. So we have the geocentric, which means centric, which means the 0 as at the center of the earth. We have the geographic. When you say geographic, we use the alternative origin. So yung ating point is on the surface of the earth. And we have the reduced or the parametric latitude. So let's discuss each of this latitude first before we combine this into one or into single illustration, and then we are going to usa-usahon na to an formulas, and then we identify the relationship between these three latitudes. So the formula for each latitudes are complex, but we can reduce that one into simpler one if we already know the relationship between the three latitudes. So let's start with the geocentric, then geographic, and then the reduced one. So let's start with the geocentric. So this is denoted as the Greek letter, we call it chi, or it looks like the trident of Poseidon. Say the geocentric latitude. So as I mentioned, from the word itself, centric. So yung origin niya is on the center of the earth. We have here at the bottom. So the 0, 0 is coming from here. For example, you have a certain portion, or this is the surface of the earth, and meron siyang point. So let's say this is the point on the ground, point P. So your geocentric latitude is actually, it is also measured from in reference to the equator. So from the definition, this is the angle at the center of the ellipse. So this one here is a portion of the ellipse. So ellipse to, we just take the quarter of the ellipse between the plane of the equator and the line to a point. So let's say this is now our ellipse. So this is the ellipse. And then, so we have here a portion on the surface of the earth, which is point P. So from point P, we draw a line directly to the center of the earth. So this is the line here, which we denote as the R, or radius of point P, right? So we draw a line from P here, from P. So we draw a line ikadto sa center ng earth. So the angle measured from that line here, from that line to the equator, or from the equator up to this line here, is called this one, the geocentric latitude. So take note, your geocentric latitude is measured from the equator to the line on the projection of a point on the surface of the earth. Okay? Again, this is 0, 0 here. So this is, so meron kang point sa earth, diretso ka sa center ng earth, and then you read the angle from the equator. So that is the geocentric latitude. Okay, so that is the latitude that we already know, that we refer to the center of the earth. So let's move to the next latitude. So the next latitude is, okay, by the way, so let's discuss muna the formula before we proceed to the next latitude. So the formula for UP here has the coordinates of X and Z. Okay, so X can be solved as, you have A. A is the semi-major axis of the ellipse, or the ellipsoid. We have the angle, the latitude, the centric latitude. We have the square root A times 1 minus E squared, or A times square root of 1 minus E squared cosine of the geocentric latitude, over the square root of 1 minus E squared cosine squared geocentric latitude. Okay, that is if you're going to compute for the value of X. Now, for the second parameter, or the second coordinates of P, we have the Z. So Z can be computed as A times the square root of 1 minus E squared y sine times the sine of geocentric latitude, over the square root of 1 minus E squared cosine squared geocentric latitude. So take note, the geocentric latitude is denoted as this Greek letter chi. Okay. So let's move to the geographic. Geographic is similar to geodetic. Again, your geodetic is similar to geographic latitude. So for the geodetic latitude, from the word itself, geodetic, in reference to the surface of the earth. So for the geodetic, so in reference sa curvature mismo ng ellipsoid. So let's say, so from the definition, this is the angle between the normal to the ellipsoid at point on the equatorial plane. So again, angle between the normal to the ellipsoid at a point on the equatorial plane. So this is what I'm saying, that we are using an alternative origin. So we are not, sa geodetic latitude, hindi tayo nagre-refer dito sa center na mismo ng Earth. But we refer to the ellipsoid itself. So this is in the ellipsoid. Okay, so this is the ellipsoid. And we have a certain point on the surface of the Earth, which is denoted as point P. So from point P, you create a projection to the ellipsoid, and then kung saan na part na mag-create ng right triangles, or magiging perpendicular yung ellipsoid mo to the point on P, the projection on P, if this point here is directly normal to this ellipsoid, then you project down. So this is now the value of the R. So this is now new R. This new R here. So the line which is measured from the equatorial plane to that point of projection, which is normal to the ellipsoid, along the P line, so this is now called the geodetic or geographic latitude. Okay, just remember geographic latitude, hindi siya papunta dun sa center, but a projection to your point P hanggang doon kung saan makikreate siya na normal or perpendicular sa ellipsoid. Okay, so if we compare this to the geocentric, yung geocentric is from point P hanggang, from point P until doon sa center. But this time, yung geodetic latitude mo at a certain point, tangent siya or normal siya sa ellipsoid. So that is the geodetic latitude. And how are we going to determine the value of the geodetic latitude with respect to this value of angle here? So meron din tayong x and z. So what is the value of x and z? So for the geodetic latitude, this is given by x is equal to a cosine of phi. So yung phi natin is yung geodetic latitude over 1 minus e squared sine squared phi. Okay, so the second coordinate is z. So this is given by a 1 minus e squared sine of phi all over 1 minus e squared sine squared of phi. So don't forget the formula. A cosine phi over 1 minus e squared sine squared phi. This is the value of your x. And the value of z is 1 minus e squared sine phi over 1 minus e squared sine squared phi, where your phi is the geodetic latitude. Okay? Now let's move to the last one. We have the reduced latitude. So the reduced latitude is medyo siya complex, but step by step natin yung definition. So from the definition, this is sometimes called the parametric latitude. So the angle, so how does the reduced latitude being computed? So this is the angle. Let's start with the angle at the center of the sphere. So isa-isahin natin. So if this is a sphere, so this circular portion here is a sphere. So let's say this one. So this is a sphere. So this is the center. Let's say this is the center of the sphere and this is the center of the ellipsoid. So para siyang yung ellipsoid mo is inscribed by a sphere. When we say inscribed, na sa loob ng sphere yung ellipsoid. So which means iisa lang yun yung kanilang center. So that is tangent to the ellipsoid. That yung sphere niya is tangent to the ellipsoid along the equator. So yung sphere mismo, so this is the sphere. This is tangent to the ellipsoid along the equator. So this is the sphere. Diba? And this is our ellipsoid. And this is the ellipsoid. Yung sphere mo at yung ellipsoid ay mag-meet along the equator. So they meet over here. And then between the plane of the equator and the radius to the point intersected along the sphere by a straight line perpendicular to the plane of the equator passing through the point of the ellipsoid. So the reduced latitude is measured from this sphere and meron tayong ellipsoid. So if this is point P, this is similar to point P kanina. So this is point P. Then magkakreate tayo ng line directly below to this P and then directly above to P hanggang doon kung saan mai-intersect niya yung sphere. So at this point here, mai-intersect niya yung sphere. So let's just say this is P prime. So let us just say that this is P prime. P prime in which yung projection mismo ng P hanggang doon sa sphere. Diba? Nag-meet yung ating line. So that P prime, yung P prime natin, we create a radius directly doon sa center. So if this is P prime, mag-create tayo ng line papunta doon sa center ng sphere. And this angle created by this line is called now the reduced latitude. Okay, so this is now our reduced latitude. So how are we going to compute the value of the x and the z coordinates of this latitude? So medyo konti lang yung formula. We have x equals to a cosine of beta, where beta is the reduced latitude. And then the other parameter is z equals to b sine of beta, where beta is the reduced latitude. Your a, that is the semi-major axis of the ellipsoid, and b is the semi-minor axis of the ellipsoid. Okay, so I hope you remember the formula between the three, the x and the z of the reduced, x and the z of the geocentric, and the x and the z of the geodetic latitude. So now let's simplify those three formulas since medyo complicated. So let's try this one. Let's have it another. So let's just say this is the equator. This is the equator of the ellipse or the ellipsoid. And then it is being inscribed by a sphere. So ito din yung magiging equator mismo ng sphere. So if this is the ellipsoid. So let's just say yung ellipsoid ay may minor axis. This one is the major axis. So a line. So this is the equator. Okay. So if this is point P. So a point P is located somewhere on the surface of the earth. And then if we create a radius from that point P to the center of the ellipsoid, that angle is called the geocentric latitude. Again, your geocentric latitude is measured from the latitude to the point onto the center of the earth. So this is chi, right? So second one we have here. So if P, so yung P natin, then we project directly, tapos we create a normal to the ellipsoid. And then this angle here is called what? So this is now our geodetic latitude. And we denote this as P, or geodetic or geographic latitude. So that is now our P. Now the last one is, diba, if we create a line from P, then mag-i-intersect siya ng isang sphere, inscribing that ellipsoid. So that point here, kung saan nag-limit yung ating projection ng P hanggang doon sa taas ng sphere is the P prime. Then we create a radius from the P prime hanggang doon sa center ng Earth. Then yung angle na makikreate natin from the equator hanggang doon sa P prime is called the reduced latitude, known as a beta. Okay, I hope you get the picture. So this is how we are going to differentiate between the three latitude. So take note, the importance of knowing these three latitude is because most of the time, the parameters are using different kinds of latitude. So some of the references are using geocentric, some are using geodetic, some are using the reduced latitude. So we must know which of this latitude and how are we going to transform one latitude to another kinds of latitude. Okay. So, ipaplastar muna natin yung mga formula. So, let's start with this one. So, we all know that tangent equals to opposite to adjacent, right? So, this is the basic knowledge of trigonometry. The tangent of the angle is equivalent to the opposite over adjacent. Now, well, our opposite, if we draw a triangle, if this is theta, right? So this is your opposite, and this is your adjacent. So in creating the triple triangle, so this is equivalent to z, and this is equivalent to your x. Sa drawing natin kanina. And then, so we have three latitudes to reduce, so geocentric and geographic. So let's start with the reduce. See, since our z in the reduce is equivalent to b sine beta, diba? Pinakita ko kanina, b sine beta. If we divide this one by x, divide by x, which is a cosine beta, so what will happen? Sine over cosine, this is equivalent to tangent, right? So this will become, if we simplify this one, this is b over a tangent of beta. So this is just similar to this one. So we just divide this to b over sine beta divided by a cosine beta. Since sine over cosine is equivalent to tangent, then we write this one as b over a tangent of beta. Okay, let's now move to the other latitude if we can simplify the formula. So for geocentric, we all know that z is equals to a square root of 1 minus e squared sine of pi over 1 minus e squared cosine squared geocentric latitude, so the square root, divided by the adjacent, which is your x, that is a times 1 minus e squared, so that is a times the square root of 1 minus e squared cosine of the geocentric latitude, all over 1 minus e squared cosine squared phi. So that is square root has square root of 1 minus e squared cosine squared of geocentric latitude. So if we take a look of this z and x, if we divide this z by x, can we now simplify the formula? Yes. So what's common? They have common on, we have similar denominators, that's which means we can cross out this one and we can cross out this another one. What else? We have also 1 minus e squared. So we can delete that and this one also. So what would be the remaining? A. We can also delete this A, right? We have A. So the remaining is we have sine over cosine. So that is equivalent to tangent of the angle or tangent of the geocentric angle. Next, we have for the geographic. So for the geographic, we have the formula is a times 1 minus e squared sine of phi over 1 minus e squared sine squared phi. If we divide it by this with the adjacent, your x, that is a cosine of phi over 1 minus e squared sine squared phi. So if we divide by z over x, can we cancel out something? Yes, we can cancel out the denominator. So we have here, since this is similar, a also, we can cancel out a. So the remaining would be, what else? Nothing more. So we have 1 minus e squared. So the remaining is 1 minus e squared. Since this is sine over cosine, so that is equivalent to tangent of phi. Okay, so this now becomes to 1 minus e squared tangent of phi, and this is tangent of pi, and this is b over a tangent of the reduced latitude. So this is can be written as b, let's use another color. So the relationship of these three latitude can be written as b over a tangent of reduced is equal to tangent of chi is equal to 1 minus e squared tangent of phi, right? So, so your b over a tangent beta is equivalent to tangent of phi and is also equal to 1 minus e squared tangent of phi. So this is just similar since we only have one point, which is 1p. But we have different position or projection at the center or either at the other portion of the region. Therefore, there has a lot of latitude. So if the given latitude is in reduced, but what you are required, um, if the given is reduced, but you are required to compute for the geographic latitude, then you first transform this reduced latitude into a geographic latitude. Otherwise, other example also using geographic latitude, and then you are required to compute the reduced latitude, then you can use these two relationships. The same goes with if you are required to compute for the geocentric latitude and you are given geographic latitude, then you first identify or transform this relationship into this type uh, uh, of latitude before you proceed with the remaining solution. So take note of the relationship between these three latitudes. So we will be having an example on the next presentation. So let's have an example. So the geocentric latitude of a point is 50 degrees north, 50 degrees 30 minutes north in a sphere having a radius of 678043 meters. Compute the geodetic latitude. How are we going to do that? If we take note that B over A tangent of the reduced latitude is equal to the tangent of the geocentric latitude is equal to 1 minus e squared tangent of what? Tangent of the geodetic latitude. And you use this relationship to compute the geodetic latitude if you are given geocentric latitude. So the given in this problem is what? Since we have the geocentric, so geocentric latitude so you've given geocentric latitude which is equals to chi. I'm sorry. So this is 50 degrees and 13 minutes north. Okay, right? And then you are given with the radius of the sphere r is equals to 6378043 meters. Then we are required to compute for the geodetic latitude phi. Okay, so we are looking into these two relationships here, right? But can you read the problem again? The geocentric latitude of a point is 50 degrees 30 minutes north in a sphere having a radius of 6378043. Again, in a sphere. So you have here a problem in a sphere. So if it is a perfect square, which means the radius is equal to all types of latitude, right? So therefore, the equivalent geodetic latitude of 50 degrees 30 minutes geocentric latitude is equivalent to 450 degrees 30 minutes north also. And the reduced latitude is also equal to 50 degrees 30 minutes north. Okay, why? Because this is a sphere. If we are referring to a sphere, wherever you go, the radius is equal in all. This is not a spheroid and this is not an ellipsoid. This is a sphere, which means in all parts, the radius is equal. So if you are asking, take note, in a sphere, the radius is equal. Therefore, the latitude is equal for all types of latitude. Okay, so this is a bit tricky question. Let's move to sample problem number 2. Okay, let's have here another example. So a point on a spheroid, so it's no longer in sphere, it's in spheroid, so it's okay. So a point on a spheroid has a value of reduced latitude of 42 degrees north and a geocentric latitude of 28 degrees north. Now compute the value of the first eccentricity. So we are going to determine first the given, then what is being required, and before we go to the solution. Okay, so we are given with the values of the following. So the given, we have the reduced latitude, which is beta, which is given by 42 degrees north. So we have here this one, 42 degrees north for the reduced latitude, and a geocentric latitude. So we have here geocentric latitude given by a high, uh, this is 28 degrees north. Now, we are going to compute the first eccentricity of that spheroid. How are we going to do that? So, our required is to compute the first eccentricity. So what we know, we already know the relationship between these two, the reduced and the geocentric. So using the relationship between the three latitude, so we have here b over a, tangent of beta is equivalent to tangent of your chi, is equivalent to 1 minus e squared tangent of phi. So where your beta is the reduced latitude, phi is this geocentric, and this one is the geodetic. So for this example, we are dealing with the reduced and then the geocentric latitude. So how are we going to compute the value of E if we already have this formula? Okay, so let's move. So we all know that B over A equals tangent 42. So we can substitute the values, and then so that we can determine the value of B over A, right? So this is tangent 42 and then tangent 48. So divide by tangent 42. If we divide tangent 48, 28 by tangent 42, the remaining will be B over A. So if we divide this one by tangent, so our remaining is B over A. So therefore, B over A is equals to 0.59052314191. So our goal is to compute the value of eccentricity. So now let's go back. What is the formula for in determining the value of eccentricity? So let's find out if we can use this value B over A to compute the value of eccentricity. So your eccentricity, di ba, is given by square root of A squared minus B squared or over A. Then we can simplify this formula para makahimukitan value ng B over A. So, kailangan natin mamilingin paagi na magamit natin ang value ng B over A para makakuha kita ng value ng E. Right? So, we can either multiply this one by the denominator or pwede natin tanggalin ang square root ni A squared minus B squared. So, if we take the square of this whole formula. So to take the square, this will become to a squared is equals to a squared minus b squared all over a squared. But again, we take the square of whole equation. So this now will become a squared minus b squared all over a squared. And then, since this is equivalent to 1, so we can make this a squared is equal to 1 minus b squared all over a squared. So what already have, since this is b over a, right? And this, we already have the value of b over a. Then we just substitute this one and take the square. So this is equal to, this is e squared minus, this is e squared equals to 1 minus b over a, right? Square. Am I correct? This is also equal to, move natin sa pataas. Let's just simplify this one. This is a squared is equal to 1 minus b over a. We already have b over a squared. And then this is equivalent to b over a squared 1 minus e squared, right? So we can compute the value of e, which is here. Just substitute the value of b over a. Now, and take the square root. So this is e is equal to the square root of 1 minus b over a squared. So your a now, then substitute the values, then your a is equivalent to 0.80, 70, 20, 700. So this is now our answer. But you can directly substitute the values here, then you can get the value of your first eccentricity. Okay, so let's have another exercises. Let's answer this one.